Ever slam that refresh button on a news site during some big story and boom, everyone's got the same update, like magic.
It's like some perfectly timed internet wave, but instead of surfers, it's servers, making sure everything's in sync.
We're talking zookeepers, right? Diving into their whole atomic broadcast protocol. Dense stuff.
Dense, but vital. Imagine 1,000 servers all needing to sing from the same song sheet. That's what Zookeeper's all about.
So no matter what chaos is going on behind the scenes, online shopping, social feeds, it all just works.
Exactly, and it's not just about keeping the lights on, but making sure they're blinking in the right order at the right time.
Like some kind of digital symphony, but way less fun to waltz to, I'm guessing.
Well, the elegance is there. Think of it like this. Every update, every change is like a perfectly time-stamped event in this massive ongoing log. We call that total order.
Total order. Got it. So no matter what, all the servers know what happened when.
Exactly. And there are a few key players. Validity means that if one server sends an update, the others actually get it. Then there's agreement, so everyone agrees on what updates actually happen.
And no one's going rogue with old information.
Right. And of course, integrity. No phantom updates, no duplicate data, just a clean, accurate history of every change.
So Zookeeper's like a meticulous record keeper for the entire internet.
In a nutshell, yeah.
Yeah.
It ensures that every server is playing its part in perfect harmony, even when things get a bit wild.
And from what I gathered, the maestro behind this whole operation is something called the ZAB protocol.
ZAB, the Zookeeper Atomic Broadcast Protocol. It's what makes this whole synchronized dance possible. Think of it as a three-phase process. Like, before an orchestra can play, the musicians need to tune their instruments, right?
Right, makes sense. Can't have a symphony with an out-of-tune oboe.
Exactly. Then they need to agree on the music, and only then can they start playing in sync. ZAB works in a similar way, with each phase ensuring that every server is ready to receive and process new updates.
Okay, I'm liking this analogy, so walk me through it. What's happening in the tuning phase of our Zookeeper orchestra?
So we're in the tuning phase, right? Is this where we bust out the tiny tuning forks for the servers?
More like a quick roll call. Say a few servers had a little network hiccup, went offline briefly, they come back, they need to catch up. That's discovery, making sure everyone's on the same page before the music starts. Catch up, got it. But doesn't someone need to lead this whole orchestra? How does Zookeeper decide who's got the conductor's baton?
It's all about who has the most up-to-date notes. Every server tracks updates, marked with what we call DRIXIDs, kind of like timestamps in the Zookeeper world. Server with the highest 6, the one that's seen the most recent changes. That's our leader.
So the most in-the-know server takes charge. Makes sense. All right, instruments tuned, conductors in place. What's next in our symphony?
Synchronization. Time for everyone to have the same sheet music. The leader shares its transaction log, basically a detailed to-do list of every update with all the other servers.
So the other servers, they're checking their own logs, making sure they match up.
Exactly. Anyone missing updates, the leader brings them up to speed. Gotta have that consistent view of the data before moving on. Can't have one server playing last week's hits.
Right, gotta keep the internet's top 40 playing smoothly. Okay, we're in sync. Bring on the broadcast.
And that's where the magic happens. Now the system's primed for new updates. Let's say a client wants to make a change. That request goes straight to the leader server.
Our digital conductor gets the first crack at it.
Right. The leader then proposes this update to the other servers. It's like saying, hey everyone, here's the next note ready to play.
But before they play it, the other servers double-check they're in the right spot, total order and all that.
Absolutely crucial. They check if they're getting the update in the correct sequence. Once a majority of the servers agree, that's our quorum, they add the update to their own logs and give the leader the thumbs up.
Harmony achieved, the leader makes it official, and the internet plays on. This whole process is wild, but you mentioned earlier that Zookeeper's built for speed too. Where does this fast leader election thing come in? Fast leader election, huh? Sounds a bit like internet democracy in action. Are we talking server campaign speeches now?
It's more like a really efficient resume swap. See, the key is to minimize downtime when a leader server goes offline. That's where fast leader election comes in, FLE. If you want to be technical.
Downtime is the enemy. So how do we get this election going? What are the rules?
Picture it like this. Instead of giving speeches, each candidate, each server presents its most impressive up-to-date resume. The one with the best track record, the most recent achievements, that's our winner.
Okay, so the servers whip out their Zixids, those timestamp things, and highest number wins.
Pretty much. The server with the highest Zixid, the one showing it has all the latest updates, he gets the nod. And because it likely has the most recent data, it can get everyone else up to speed really quickly. Efficiency is key.
Makes sense. But this paper we're looking at, it also talks about Zookeeper running into some, well, real-world snacks, bugs, to be precise.
Ah, yes, those pesky bugs. The paper highlights a couple of interesting cases, Zookeeper 335 and Zookeeper 1154. They really show how tricky it is to build these perfectly in-sync systems. Even tiny hiccups can turn into big headaches if you're not careful.
Give me the lowdown on these bugs. What kind of trouble did they cause?
So Zookeeper 335, that one exposed a vulnerability in how the system handled those moments when a new leader gets elected. Remember those epoch numbers we talked about? They're like chapters in the Zookeeper storybook, marking big changes like a new leader stepping in. Well, there was this scenario where a server could think it had the conductor's baton, but it hadn't actually gotten the official nod from the rest of the orchestra, like taking the podium too early.
And that led to, what, a musical train wreck?
Not a total meltdown, thankfully, but it did cause problems. Some servers got stuck in a loop, constantly trying to pick a new leader, which meant delays in actually sending out updates. It highlighted how important clear communication is, even in those split-second handoffs.
Communication is key. All right, what about Zookeeper 1154? What went wrong there?
That one was a bit trickier. It involved the system potentially applying updates out of order. And we know how vital total order is, got to keep that timeline straight.
Right, like playing all the notes in the right order, otherwise the whole symphony goes wonky?
Precisely. There was this specific sequence of events where a server might miss an update, think it was outdated, and should be tossed out when it should have been included. Just a small slip-up, but enough to throw things out of sync.
Wow, so even the tiniest error can have ripple effects. It's amazing how much work goes into keeping everything running smoothly behind the scenes.
It really is. And what's fascinating is that while these concepts might seem abstract, they're the backbone of so many things we use every day. Online shopping, banking, social media, they all rely on these systems that need to be in perfect harmony across huge networks.
It's like a hidden world of digital choreography. Next time I hit buy now or send a message, I'll be thinking of all those servers working overtime to make the magic happen.
It's quite impressive when you think about it. So
Mhm.
here's something to ponder. Now that you've seen how Zookeeper solves these coordination puzzles,
Mm.
how do you think other systems, maybe ones using totally different technologies, might be tackling the same challenges? What kind of trade-offs do they make between speed, complexity, and that ever-important need for rock-solid reliability?